Every one of those loads asked Ollama to keep the model warm for 10 minutes. Read the last column down the page. After the second load, there are 2 models sitting there. After the third, there is 1. The 2 that vanished had been alive for about 5 seconds. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. This is the question everybody hits on day 2 of running models locally. You have one model for chat, another for code, maybe an embedding model for search. Can you keep them all warm so nothing has to load again? Ollama gives you a setting for exactly that. It is called Keep Alive, and every request in this episode asked for 10 minutes. So this is not a story about a default timing out. It is a story about what that request is actually worth. Here is what is being read and how. After every load, I read Ollama's own table 1 second later. Resident size, and which models are still there. Load times come from Ollama's counter rather than a stopwatch. One detail in that file is a mistake I made and had to fix. The first version stopped only the models it was about to load, so leftovers from an earlier test were still sitting in memory and quietly changed the answer. It now stops everything resident and refuses to run if anything survives. A benchmark that starts on a dirty machine measures the dirt. So the latter. Load a 4 billion model, then a 7, then a 9, then a 27. The 4 billion model settles at 5.7 gigabytes. Add the 7 billion one and both stay 12.3 gigabytes between them. Good. 2 models warm, exactly what you wanted. Then load the 9 billion model and both of them disappear. Look at what replaced them. 8.2 gigabytes. A machine with 32 gigabytes of memory has just thrown away 12.3 gigabytes of perfectly good models to make room for 8.2. Add those together, and you get 20.5, which fits with room to spare. My first thought was that this is simply a cap on how many models you get. 2 and no more. That is a tidy explanation, and it took one more experiment to kill it. Same machine, same 10-minute keep alive, free models loaded. Smallest first. All 3 are still resident at the end, 16.7 gigabytes between them. So there is no 2 model limit. In this order, 3 is fine. Which means the rule is not about how many models you have. It is something to do with what the incoming model demands at the moment it loads. And that is where the second experiment gets genuinely strange. Start with Llama 3.2. That is a 2 gigabyte download. It reports 10 gigabytes resident. 5 times its own file size. That gap is the context window. A model does not just load its weights. It reserves room to hold a conversation, and on a fresh install, that reservation can dwarf the model itself. Nothing in the download size tells you this is coming. Now watch what evicts it. Llama 3 at 3.8 gigabytes. A small model pushed out one more than twice its size on a machine with far more memory than the 2 of them needed together. And then the third load, 2T-Wen 3.5 at 4 billion parameters, sits down next to Llama 3 quite happily. 2 models, 9.5 gigabytes, no eviction at all. I cannot give you the rule. What I can tell you is what the pattern points at. The memory Ollama reserves, while it is loading a model, is larger than the number it reports once loaded, and that reservation is what triggers the eviction. From outside the process, I can see the consequence, not the calculation. So I am not going to invent a formula for you. What I will not do is pretend the observation is useless, because it is not. The first practical thing is that the resident number is the one that matters, and it is not the download size. If you are budgeting memory by adding up what you pulled, you are working from the wrong column. Load the models and read Ollama's. That is the number. The second is that Keep Alive is a request and not a promise. It sets how long a model may sit idle before being released. It does not reserve anything, and it does not protect a model from being evicted the moment something else needs room. If your design assumes a model stays warm because you ask nicely, it does not. The third is the reassuring one, and it is worth ending on because the first 2 sound worse than the situation actually is. That is the end of all 3 runs side by side, re-requesting the first model each one loaded. Where the model was still resident, it answered in 0.3 seconds. That is a warm hit, and it is effectively free. And when a model has been evicted, getting it back costs 3.6 seconds against a 2.4 second first load. For Llama 3.2, 1.6 seconds against 2.5, faster the second time because the file was still in the operating system's disk cache, even though Ollama had let go of it. So eviction costs you seconds. Not minutes, not a redownload. If a model gets thrown out, the user waits about as long as they would have waited the first time and often less. That reframes the whole problem. You cannot reliably plan which models stay warm, and the numbers Ollama shows you will not let you predict it. But the penalty for guessing wrong is a few seconds, so the right response is to stop trying to outsmart the schedule and simply accept an occasional reload. If you want to know what your machine does, this takes about 2 minutes, and the one-line version is to load what you care about and read Ollama CS. There are 2 environment variables that change this behavior. One for how many models may be resident, and one for the default idle timeout. Neither was set here, so everything you have seen is out of the box. I would measure before touching either, because the reservation is bigger than the reported number and raising the limit will not buy you as many warm models as the arithmetic suggests. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.